Assalamualaikum. Hi everyone. So we meet again in another video for chapter 3 electrochemistry. This video is for subtopic 3.2 Nernst equation, and at the end of this lesson you should be able to write Nernst equation for a given galvanic cell, explain the factors that affect the cell potential, use the Nernst equation to determine the cell potential or EMF, concentration or partial pressure of a species, and equilibrium constant K when E cell is 0. And lastly, predict the spontaneity of a cell reaction. So without further ado, let's start. So first, we're going to talk about Nernst equation. So what is Nernst equation? The one that we have discussed so far in 3.1 is all about how to find the E0 cell, the standard reduction potential for cell E0 cell. Okay, and then we use the value of the standard reduction potential of the half cell, which is the E0 half cell, either E0 cathode or E0 anode. Okay, what's the difference between the one that we have learned and the one that we're going to learn today? So let's take a look. So Nernst equation. When are we going to use this Nernst equation? So Nernst equation can be used to calculate E cell for any chosen concentration. So this is not a typing error. This is as what you see. Okay, the one that we have learned for 3.1 is for E0 cell. What does that not sign means? It means all the reaction happens at standard condition. Okay, still remember your standard condition? So for E0 cell, it must occur at standard condition. Okay, our standard condition is 1 atm pressure, 1 molar concentration, and 25 degrees Celsius or 298 Kelvin. Okay, but for E0 cell, the temperature can be vary. It can be at any temperature, and also it can be at any concentration and pressure. In other words, it's not at standard conditions. Okay, for this one, I wrote it down as any chosen concentration because usually our E cell, we calculate it at still 1 atm pressure and 25 degrees Celsius. It's just that we change the concentration. But can I change the pressure and temperature? Yes, you can. Now, let's take a look on what is the Nernst equation. How does the Nernst equation looks like? Okay, so this is our Nernst equation. So the equation will be E cell equals to E0 cell minus 0.0592 over n log concentration of product to the power of x over concentration of reactant to the power of y. So now let's take a look one by one of all the terms that we have here. The first one here, product over reactant. So this might be familiar with you because we use this product over reactant so many times last semester, okay, on our chapter 6 and also chapter 7. Okay, so this is our reaction quotient Q. So for last semester, for chapter 6 and chapter 7, we find the value of K. K is equilibrium constant. But here, since it can be any concentration at any time, so that's why it is our reaction quotient, product over reactant. So the value of X and Y is based on your balanced chemical equation. So let me give you one example how you're going to write down your Q over here. So let's say the equation that I have, the balanced equation that I have is zinc solid plus nickel 2 plus aqueous to produce zinc 2 plus aqueous plus nickel solid. Okay, how am I going to write down my Q, my reaction quotient? So our reaction quotient will be the product over reactant. So this is our product and then this is our reactant. So bear in mind, the way of you to write down your Q is the same as the one that we did for chapter 6 and chapter 7, where we will only take the one that we're going to write down in our Q is aqueous and also pressure. And also gas. Okay, only these two terms that we're going to choose to be written down for our quotient. And a bit special for the Nernst equation, we're going to combine the partial pressure and also the concentration. So if, let's say, inside your balance equation, you have gas, so you will write it down over here as well. Later, I'm going to show you in one of the example. So, coming back to this, so how are we going to write down the quotient? So our Q over here, concentration of product over concentration of product over concentration of reactant. So you need to make sure that the equation over here is balanced. How are you going to balance a redox equation? Okay, simply by check the half equation, the anode and the cathode, the reaction for oxidation and reduction, and then balance the number of electrons for you to get a balanced redox equation. So the Q here will be our reactant is zinc. So concentration of zinc 2 plus. So since here we have to the power of 1, so you don't have to write 1, meaning our X is 1 over, so I just put it here as 1, but if you don't write it, it's okay because it's 1, and over nickel 2 plus to the power of 1. As you can see over here, I did not take the value of zinc and nickel. Why? Because the zinc and nickel is in solid state. Okay, so that's how you're going to write down your Q. Okay, your reaction quotient. Concentration of product over to the power of X over concentration of reactant to the power of 1. And everything over here, okay, will be log. Okay, so that's the first one. The second one is N. What does N stands for? It stands for the number of electrons involved in the reaction. Okay, so where are you going to find this number of electrons? So the number of electrons you will find while doing the overall equation. Okay, the number of electrons that you cancel out, that is the total number of electrons. Okay, and then the value of E naught cell. So the value of E naught cell is the same calculation that we have learned before, which is E naught cell equals to E naught cathode minus E naught anode. And this value, the standard reduction potential of cathode and anode, the half cells, you will get it from the SRP table, or the question will give you the value. Okay, you just need to determine which one is for cathode, which one is for anode. Okay, so this is the Nernst equation, and if you look at your lecture note, you will have a few Nernst equation. Okay, so the one that you need to memorize is this one. So you need to make sure that you memorize it correctly. E cell equals to E naught cell minus 0.0592 over N log concentration of product to the power of X over concentration of reactant to the power of X. Okay, and then this is one term. Okay, later on the calculation, I will emphasize this again. So now, before we proceed with the calculation itself, let's take a look on what are the factors that affect the cell potential, the E cell. Okay, what factors can increase the value of E cell, or what factors can decrease the value of E cell? So let's take a look. Okay, now this is our Nernst equation. So this is actually the original Nernst equation. Okay, E cell equals to E naught cell minus RT over NF ln concentration of product to the power of X over concentration of reactant to the power of Y. So this is our Q. Okay, like I said before, this is the original Nernst equation, but you don't have to memorize this equation. So I'm just showing you this equation to tell you about what are the factors that can affect the value of E cell. Okay, if you look on your lecture note, there will be steps on how to get the E cell, the Nernst equation that we used before. Okay, but do you need to know the steps? Do you need to know how to derive the Nernst equation? No, you don't have to. Just use the value. Okay, later, if you look on your lecture note, if you want to look at it, the R here is your gas constant, which you will use the value of 8.314. Okay, and then N is still the number of mole that we use in the reaction. Okay, and then F is Faraday constant. 1 Faraday equals to 96500 coulomb. This one later we're going to use it on 3.3. Okay, and then 3.4. And then ln, and here is your Q. So our target right now is what is the value that will affect the E cell over here. Okay, so in our discussion, our target right now is we want to have a high value of E cell. So as you can see from what I have highlighted here, we have two factors. Okay, the Q, the concentration over here, and also T, the temperature over here. So the first one, temperature. Okay, like I mentioned before, our target right now is for the E cell to be high. I want a big E cell. Okay, so the value of the E naught cell is constant. Okay, this value over here, this one is constant. Okay, what do I mean by constant? The calculation is based on the value given in the SRP table, which we cannot change. Okay, so that's why there's nothing we can do on the E naught cell. Okay, so to get a high value of E cell, we need to make sure that the total overall value of this part over here, it must be small. Okay, so that we can get a maximum number of or the maximum value of E cell. So to get a very small value over here, if I want my E cell to increase, I need the temperature over here to decrease. Okay, so this is the first factor. Okay, to have a big E cell, I need to have a small temperature. Okay, the first one. Next, the second one is on the concentration over here. Okay, so for concentration, since I want the total value over here to be small, okay, what do I need to do? Okay, so the overall value, so this is your Q. Okay, so this is your Q. So the value of Q, it must be small. If the value of Q is small, meaning the overall value for this will also be small. Okay, so I can maximize the number of E cell. So to get a small value of Q over here, what we need to do is, okay, the E cell will increase if the concentration of the product is decreased, because like I mentioned before, the target is we want the value of Q to be small. So for the value of Q to be small, the concentration of product needs to be small as well. So decreasing the concentration of product will overall increase the E cell. And then the same thing, to get a small value of Q over here, what we can do is increase the concentration of reactant, meaning have a big number of reactant. Okay, have a high concentration of reactant. So once we have a high concentration of reactant, the overall value of Q will be small. So the overall E cell will increase. Okay, so this is your factors. So please remember, so what you need to remember is how to increase the concentration, the value of E cell first, decrease the temperature. Second, okay, over here, okay, increase the concentration, decrease the concentration of the product, and then third, increase the concentration of the reactant, and vice versa if you want to find a smaller E cell. Okay, next, we're going to look on the spontaneous and non-spontaneous reaction, or sometimes in exam, in question, they call it as the spontaneity of the reaction. So if you find from the question, it says, is the reaction spontaneous? Or the question said, determine the spontaneity of the reaction. So it's the same thing. Actually, this part we already discussed it in the previous video. Okay, but there will be slight difference. Okay, so let's take a look on what's the difference. So for the spontaneous and non-spontaneous reaction, spontaneous reactions will have the value of E cell bigger than 0, non-spontaneous reaction less than 0, and the cell reaction, if it is at equilibrium, the value of E cell equals to 0. So the only difference here is the E cell. Okay, here, if previously in the previous video I wrote as E naught cell. Why? Because the reaction happens at standard condition. So to calculate the E naught cell, E naught cathode minus E naught anode. But here, okay, for to determine the spontaneity, spontaneous or non-spontaneous reaction for a cell that is not at standard condition, meaning other than 1 molar and other than 1 atm pressure, and also besides 25 degrees Celsius. So the value that we're going to look is the value of E cell, meaning this value of E cell needs to be referred by the Nernst equation, which the Nernst equation just now is E cell equals to E naught cell minus 0.0592 over n log Q. Okay, so we calculate this value and then we compare. If it's more than 0, it's spontaneous. Less than 0, it's non-spontaneous reaction. And if you get the value equals to 0, meaning the reaction is at equilibrium. So what does it mean by the reaction is at equilibrium? Okay, at equilibrium means, so at our log Q is log concentration of product over concentration of reactant. Okay, to the power of X to the power of Y. If the value or the concentration of the product and the concentration of the reactant is the same, meaning the reaction will become at equilibrium. Okay, so once the reaction is at equilibrium, you will calculate and you will get the value of E cell equals to 0. Okay, and then there will be a specific or a new explanation for this E naught cell. So let's take a look on the next slide. Okay, so at equilibrium, concentration of the ions in the two compartments are the same. This is just like I mentioned before. So there will be no net reaction occurs. Okay, no net reaction meaning the value of Q, our Q product over reactant. Okay, so basically this is our Q. But since the concentration of the product equals to the concentration of the reactant, okay, it is said that there is no net reaction. So at this moment, the reaction is at equilibrium. So the value of Q, we can put it as K. Still remember your K? K is your equilibrium constant. Okay, so E cell, the cell potential is equals to 0. And this is a very important piece of information later to be used when doing the calculation. Okay, so now let's move on. So now let's take a look on the example calculation on E cell using the Nernst equation. So here I give you 4 different calculations for 4 different examples of situation. So let's take a look at the examples one by one. So example number 1. So consider this electrochemical reaction, zinc solid plus nickel 2 plus aqueous to produce zinc 2 plus aqueous plus nickel solid. Okay, the standard cell potential in a cell is 0.51 volt. So find the potential, the cell potential E cell if nickel 2 plus concentration is 5.0 molar and zinc 2 plus concentration is 0.050 molar. So as you can see over here, the question already gives you the value of the E0 cell over here. Okay, so you don't have to find what is the value of the E0 cell. It's already given. And the reaction occurs not at standard condition. Why? Because the concentration of Ni is 5 molar and the concentration of zinc over here is 0.05 molar. If it's at standard condition, it must be 1 molar. So before we go on solving this question, I will give you the general steps on how to answer question regarding the Nernst equation. Okay, so let's take a look at all the steps. Okay, so I'm going to show you the steps on how to answer question related to E cell using the Nernst equation. Okay, so let's take a look at the step one by one. Okay, first write down the half equation at anode and cathode. So this half equation, so if it's at anode, meaning the reaction will be oxidation. And then if the equation is at cathode, okay, meaning it's for reduction. So you must write down first the equation. Okay, how do you determine which one is anode, which one is cathode? Okay, that will be based first how to choose anode and cathode. There will be 2 types of question. One, okay, I do it in purple color. Okay, either you found it from the value of the E0 half cell. Okay, this one you need to determine yourself. Okay, for this one, the question will give you the E0 half cell and then you determine the more positive value will become your cathode. The less positive will become your anode. Or there will be some question, the question already give you the balance equation. Okay, so if the balance equation is already given, your anode and your cathode will be based on the balance equation. Okay, even though the value of the E0 half cell is given, but if equation is already given as well,
So anode cathode follow the balance equation. So that will be the first one. So step number 2, write down the overall equation. So meaning from here, okay, you already write down your anode and cathode half equation. So you will have your overall equation over here. How do you write down the overall equation? So you need to make sure that you can cancel out the number of electron. The number of electron must be the same. Okay, so why does the second step, writing down the overall equation, is very important? Because from the overall equation, there will be two things that you need to determine. Okay, first is your Q expression. This Q expression can only be written down if you have the overall equation, overall balance equation. And then the second one is to find N. Okay, still remember what is our N? Number of electron involved in the reaction. Okay, involved, okay, I spell it wrongly. Okay, number of electron involved in the reaction itself. Okay, so that's why it is very important to write down the overall equation. Okay, the third step is to find the E0 cell. How are you going to find the E0 cell? By using the equation, the E0 cell equation, which is E0 cell equals to E0 cathode. Okay, E0 cathode minus E0 anode. And the value of the standard reduction potential or the standard electrode potential of cathode and anode, either you will find it from the SRP table, or the question will give you the value itself, or the question will already give you the E0 cell value. So depends. So if the E0 cell is not given, you need to find it. But if it's already given, then just use the equation. Okay, so that it's step number 3. So the last step, step number 4, is use Nernst equation. So if you look closely over here, I did not put the fourth step as find E cell, because it's not necessarily you will find the value of E cell, but you must use your Nernst equation. So let me just write down your Nernst equation over here. So E cell equals to E naught cell minus 0.0592 over N log Q. So Q, concentration of the product, to the power of X over concentration of the reactant to the power of Y, where X and Y is based on your balance equation. Okay, so the question that can be asked either find E cell. So if you want to find E cell, you need to have the value of E naught cell and you need to have the value of the concentration. At the same time, in different question, it can also ask you find what is the concentration of reactant or what is the concentration of the product. So at that moment, the value of E cell is already given. Okay, but you will still use the same Nernst equation. So let me just highlight back the steps for you. So step number 1, okay, write the half equation at anode and cathode. Step number 2, write down the overall equation. So overall equation, what does it use for? To find the Q expression and then to find N. Okay, step number 3, calculate the value of E naught cell. And then step number 4, write down the Nernst equation and use the Nernst equation to answer your question. So now, let's go back to our example 1 just now. Our example 1. So, let's do this step by step. So, like I mentioned before, our first step is to write down the equation for anode and then the equation at cathode. Okay. So, label as anode and cathode. Okay. So, determine from the balance equation over here. So, zinc 2 plus, Ni 2 plus, and Ni. Okay. Zinc to form zinc 2 plus, meaning this is an oxidation reaction. So, since it is oxidation reaction, since it is an oxidation reaction, meaning this is your anode. Okay, and then nickel 2 plus to form nickel. So, this is a reduction reaction. So, reduction, this is your cathode. Okay, so let's write down our equation. So at anode, okay, we have zinc solid, oxidized to produce zinc 2 plus, aqueous plus 2 electrons, and then at our cathode, nickel 2 plus aqueous plus 2 electron to produce nickel solid. Okay, so this will be your first step. In exam, please do not label 1, 2, 3 and 4. Okay, it might confuse the examiner. I'm just showing you number 1, number 2, number 3 and number 4 just for you to know the flow. Okay, next, the second step, like I mentioned before, we need to write down the overall equation. So from here, the overall equation, like I mentioned before, you need to make sure that the number of electron is the same. So at anode, 2 electron, cathode also 2 electrons. So we don't have to do anything to the half equations over here. If let's say the number of electron is not the same, what you need to do? Times by a number so that the number of electron for both half equation is the same. Okay, since it is the same, so we can cancel. Okay, and then write the equation. So the overall equation, okay, so overall equation, it will be nickel 2 plus, aqueous plus zinc solid to produce nickel solid plus zinc 2 plus aqueous. Yes, actually you already have the equation here, but why it is important to still write it down over here so that you know what is the number of electron used. Because if you just write down the equation for anode and cathode, the half equation only, maybe you will miss out the number of electron. So from here, okay, on step 2, you can note, so N, number of electron used is 2 electrons. Okay, even though here we have 2 and then 2, but actually the number of electron produced, okay, the number of electron produced from anode is 2, and this 2 electron is used up by cathode here. Okay, used up at cathode. Nickel accept the 2 electron, meaning the total number of electron that involved in this reaction is only 2. So N is 2 electron, and then your Q. Okay, so Q is concentration of product over reactant. So our product here, zinc 2 plus, we only will take aqueous and gas. Okay, zinc and nickel. So we will exclude zinc solid and nickel solid. So write down the Q as zinc, concentration of zinc 2 plus over concentration of Ni plus. Both are to the power of 1 because the coefficient over here is to the power of 1. Okay, so that will be the second step. Overall equation to find what is the number of electron and to find Q. So the third step is for us to find what is the E naught cell. Okay, so write down E naught cell. In this question, the value of E naught cell is already given to us. So just write it down as part of the information so that you will not miss out the information over here. Okay, so it is 0.51 volt, positive 0.51 volt. So you can straight away proceed to the fourth step, which is the Nernst equation. So let us write down the Nernst equation first. So E cell equals to E naught cell minus 0.0592. Make sure you remember this number correctly because it will not be given in exam. Okay, over N log concentration of zinc 2 plus, your Q over concentration of Ni plus. Please, Ni2 plus. Please make sure that you write down the Nernst equation according to the question. Change the Q part over here. The N, just leave it first. Okay, later we substitute. But the Q part over here, please make sure you use the species inside the reaction. So once we have written down the equation correctly, so next is to substitute all the values to find what is the value of E cell. So substitute the value. So our E naught cell 0.51 minus, so all of this 0.0592 over N is 2, the number of electron over here. Okay, and then log concentration of zinc 2 plus. So this is the concentration of zinc 2 plus. So 0.050 over concentration of nickel is 5. Okay, so substitute the value of the nickel, which is 5, and then use your calculator, okay, wisely and very carefully find the answer, and you will get the value of E cell positive 0.57 volt. Make sure you write it down with the unit. Without the unit, you will not get marks for the answer. Okay, so that's how you solve question number 1.
So, question number 2. An electrochemical cell is represented as PT, H2, H+,
H2 gas 1 atm. Okay, before I forget, please correct your equation. It's supposed to be gas 1 atm over here. I forget to put the face. So please correct the question on your notes. Okay, H plus aqueous X molar, and then the salt bridge Ag plus aqueous 1 molar and Ag solid. So if the value of the cell potential is 1.198, so look carefully, this is cell potential, meaning this is E cell, not E naught cell. If it's E naught cell, it will say standard cell potential. This is just cell potential. So E cell is equals to 1.198 volt. So determine the concentration of the H plus solution. So now the question asks for us to find what is the value of X, what is the concentration of H plus used, and it gives us the value of E cell, meaning this reaction is done not under standard condition. Okay, so let's take a look on how to solve this question.
Now, the steps are the same. Step 1, 2, 3, and 4. 4 steps calculation. Okay. So, on our left hand side over here, this is our anode. And on the right hand side over here, this is our cathode. What you need to see over here is, here, okay, PT solid, H2 gas 1 atm, okay, and then H plus aqueous X molar. So this is actually the equation for your She. Okay, why do I highlight this? Because later when you are writing down the equation for anode, okay, the oxidation equation, reaction, we will not include PT because platinum is not part of the reaction. It's an inert electrode, so it will not involve in the reaction. The only reaction that will occur is oxidation of hydrogen to become H plus ion. So now let's write down the equation. So I just label this as step 1. Okay, anode, we will have H2 gas to produce H plus aqueous, 2 H plus aqueous plus 2 electrons. Okay, so this is step anode. And then at cathode, okay, we will have the reaction from silver plus to silver solid. So Ag plus aqueous plus electron to produce Ag solid. Okay, the next part is for us to find the second step, find the overall. Okay, so for the overall over here, make sure that the number of electrons is balanced. So 2 electrons, this is 1. So what you need to do, times everything over here with 2. Once you have that, then you can cancel out the electron and have the overall equation. So H2 gas plus 2 Ag plus aqueous to produce 2 H plus aqueous plus 2 Ag solid. So from this, we can see that the value of N is 2 electron and our Q, okay, please pay extra attention over here. So like I mentioned before, Q, product over reactant, we will take gas and aqueous solution. So we have, not this one, we have H plus aqueous, Ag plus aqueous, and also H2 gas over here. So your Q, it will be, so the product is concentration of H plus to the power of 2, because you have 2 coefficient over here, over
Ag plus, okay, so Ag plus to the power of 2 and hydrogen. Hydrogen is gas, so you will write down in terms of partial pressure and we will mix inside the Q expression over here. So it will be partial pressure of H2. Make sure you write it correctly. Partial pressure H2 to the power of 1 because the coefficient is 1 over here. Okay. Once you've done step number 2, let's proceed with step number 3. So step number 3 is to find the E0 cell. Okay, so for this question, the E0 cell is not given to you. So you need to find the E0 cell by finding what is the value of the standard electrode potential for cathode and anode. So E0 cathode minus E0 anode. Okay, so our cathode is E0 silver minus, so like I mentioned before, our anode is actually our She. So E0 She. Still remember what's the value of She? She will be 0.00 volt. So for silver, find the value and you will get the value from the SRP table is positive 0.80, so minus 0. So we will get positive 0.80 volt for the E0 cell. Okay. So next, step number 4. Okay, step number 4, write down the Nernst equation first. So E cell equals to E0 cell minus 0.0592 over n log. So write everything that you have over here. Okay, so concentration of H plus to the power of 2 over concentration of Ag plus to the power of 2 and partial pressure of H2. Okay, some of you might wonder, is it compulsory to write down n equals to 2 and Q over here? No, it's not compulsory. You can straight away write it down in step number 4. Okay, but you need to make sure that you write the correct thing. You write the correct expression. So I just write it down for you over here so that you can see the two information over here. We get it from the overall equation. So once we written down the equation, the Nernst equation over here, so substitute all the value. So the E cell is given to you, so 1.198. The E0 cell, the one that we have calculated over here, 0.80 minus, okay, 0.0592. Why do I put bracket over here? So that you can see clearly this value will times the log value over here. Okay, so our n is 2. Okay, then log the concentration of H plus squared, the one that we want to find. Okay, Ag plus to the power of 2. So we get the concentration from here, from the cell notation, 1 molar. So we'll write down 1 to the power of 2. Make sure you substitute the correct value. And then the partial pressure of the gas, of hydrogen gas, is 1 atm. So 1. Okay, and then close our bracket. Okay, so calculate by using your calculator. So I write down these steps over here. You can try it on your own. So you will get the value here, okay, log concentration of H plus to the power of 2 as negative 13.4459. Make sure you tick at least 3 or 4 decimal places, and then okay, to remove the log, Okay, it will be 10 to the power of negative 13.4495. Okay, and then to find the concentration of H plus, okay, you will get the answer as 1.89 times 10 to the power of negative 7 molar. So make sure it is with the correct unit. So this will be your final answer for example 2. So, question number 3. Calculate K for a zinc copper cell. It's a very simple question. The question asks for you to find the value of K. So, what you need to see over here is you need to be able to understand what is K. Still remember, again, I mentioned already, K is your rate, constant, equilibrium constant. So, this equilibrium constant, it will have a relationship with our Q. So, where do we find our Q? Q will be found in our Nernst equation. When? At what time will the value of Q equals to K? So, Q equals to K is when the value of the E cell is equal to 0. So, this one is a very important piece of information. So, once the question asks for K over here, meaning the reaction is at equilibrium. Okay, at equilibrium where the value of the E cell will automatically be 0. So, we will use this piece of information and then straight away do our calculation. So, let's calculate. Okay, so to save some time, I already written down all the answers, almost all of the answers over here, step by step. So, step 1, okay, your anode and cathode. So, how do I determine this anode and cathode? So, look at the value of the reduction potential of electrode given. Okay, so since for the copper it's more positive, so this is our cathode. So copper 2 plus will undergo reduction to form copper, while this is our anode. Okay, where oxidation process will occur over here, zinc to become zinc 2 plus. So that's the first step. And then the number of electrons is already the same, so I can straight away cancel out the equation, and then I write down the overall equation. So from this overall equation, the number of electron is 2, n equals to 2, and the value of Q I straight away put as K because we want to find K. Okay. So step number 3 is to find the E naught cell. So write down the equation E naught cathode minus E naught anode, substitute the value, and then you will get the value of E naught cell as positive 1.10 volts. Now, so the moment of truth is for step number 4. Okay, you have written down your Nernst equation over here, and then please note something. Okay, so at equilibrium, the value of E cell will equals to 0. So you need to write this down so that it is clear that the value of Q equals to K. So once you have written down this statement, then you can substitute all the values over here. So the E cell will become, okay, let me use blue color pen. E cell is 0. E naught cell is positive 1.10 volts minus 0.0592 over N is 2, and then log K over here. So this will be your equation. So once you have written down everything like this, okay, at one point you will get this 0.0296 log K equals to 1.10, and then find the value of K, the final answer you will get as 1.45 times 10 to the power of 37. So this will be your final answer. Okay, and our equilibrium constant, okay, it must be capital K over here. It will not have any unit, so it is unitless. So that is the calculation for example 3.
So last example, example 4. Will the following reaction occur spontaneously at 25 degrees Celsius? So if Fe2 plus is 0.6 molar and Cd2 plus is 0.10 molar. So what is the equation? The equation is given here. So if the equation is given here, okay, you will need to determine the anode and cathode from the balance equation. Even though the question gives you over here the value of the E0 half cell for iron 2 plus and cadmium 2 plus, but you will not use these two values to determine the anode and cathode. Anode and cathode will be based on this. Okay, so what you need to do here is, so match it, okay, and then find which half equation will undergo oxidation, which one will undergo reduction. So for iron over here, it's positive 2 to become 0, meaning Fe2 plus undergo reduction. So if it undergoes reduction, it will be at cathode. Okay. While for the cadmium, okay, 0, positive 2, so it is an oxidation process, so it will be at anode. So the equation at cathode and also anode will be based on this equation. Okay, regardless what's the value given over here. Okay, so now let's take a look at the calculation.
Okay, so for example 4, so this is the question just now. So I already written almost all of the answers. So at anode, Cd solid to become Cd2 plus, cathode Fe2 plus to become plus 2 electron to become Fe solid, and this is the overall equation. Okay, it is the same as this one, just the position is different. So the number of electron is 2, and this is the Q. So this is the E0 cell. Step 3 to find the E0 cell. So from this step 3, as you can see, the value of the E0 cell is negative 0.004. So what does this value mean? So if the reaction, okay, is at standard condition meaning 1 molar, 1 atm pressure, and then 25 degrees Celsius, since we get an E0 cell less than 0, meaning reaction is non-spontaneous. If we have a value of negative, reaction is non-spontaneous. In other words, the reaction may not occur. Okay, so that's why we need to alter the condition. We change the concentration so that we can get a spontaneous reaction. We can get a positive value. So that's why over here we use a different concentration. Iron 0.6, cadmium 0.1. So we want to check, is this condition can give us a spontaneous reaction? Will it give us a positive EMF value, a positive E cell value? So this is your Nernst equation, okay, and then we're going to substitute all the informations that we already have. Okay, so the value of the E cell, okay, we need to find that. And the value of the E naught cell is negative 0.04 minus 0.0592 over 2, okay, log, so concentration of CD2 plus is 0.010 over Fe2 plus 0.6 and E cell over here. So calculate the value and you will get the value of the E cell as, let me find the answer. Okay, E cell is equals to positive 0.013 volt. Okay, so now once we get the value over here, look back at the question. The question asks, will the following reaction occur spontaneously? So we need to answer that. Okay, how are you going to answer? So you're going to answer by stating the statement. Put the statement. So E cell, make sure you write down E cell, not E naught cell. Okay, E cell is more than 0, so reaction is spontaneous. Okay, so in other words, this example shows that some reaction might not occur at standard condition, but as we can change the concentration, we change the condition, the reaction might occur. So we just need to find what is the suitable condition for a certain reaction like this. Okay, so that will be all for example 4. So these 4 examples will be the question that might come out in your exam for 3.1 and 3.2. Okay, so please make sure when you read your question, read carefully. Okay, do you need to use Nernst equation or not? Okay, so if it's at standard condition, there's no need for you to use the Nernst equation. But if the question mentioned E cell or the concentration changes, it's not 1 molar, or the reaction is done not at 1 atm pressure. So all of this information leads to us using the Nernst equation to find the value of the E cell. Okay, so that will be all for the calculation for 3.2.
Okay, so I hope this video will help you on trying to answer the exercise question that I give you. Okay, so if you have any question, if you have anything that you don't understand or any terms that you don't understand, or you want extra explanation, okay, you want me to explain it in Malay, so just ask me and then I will make a separate video for you. So that's all. Thank you for listening till the end. Until we meet again in another video. Thank you.